Sichukweke. I'm the founder of Clinton Innovation Center, ABA, which is Nigeria's first makerspace. I want to welcome all of you, both those that are watching us online and those that are physically present. I want to welcome all of us to the final day of the Nigerian Genius. So today we shall be evaluating, we shall be texting, assessing, scoring, and evaluating the finalists, the 4 teams represented here. I want to once again congratulate the 4 teams which made it to the finals of the Nigerian Genius 2023. We have, once I call your name, you clap for yourselves. So we have YABA College of Technology, YABATECH. We have University of UNIUYO. We have Ahmadu Bello University Zaria, ABU. And then we have Federal University of Technology, MENA, FUTMINNA. So these finalists have spent over 2 weeks at the premises of the Advanced Engineering Center, ABA, interacting and romancing with different advanced manufacturing equipment and learning advanced engineering skills, learning industry skills, and applying those skills that they've learned in solving real problems. So today we shall be evaluating the class projects that you did in the different classes that you took, in addition to the overall challenge that you solved. But before I go forward, we have the privilege and honor to be graced by a team of experts in our jury. Clap for them, clap for them. Professionals, engineering professionals in different fields, sectors, with different experiences. So let me start with the first person on my right, Engineer Mike Ekuribe. Can you just wait for us? Just wait for us. So he is a lecturer at the Abia State Polytechnic, Aba. Clap for him again. And he has been a friend of Clinton for so many years. Clap for him again. Next to him is Engineer Cletus Eko. Clap, clap, clap. Engineer Cletus is the CEO of C Plus Industries Limited. He is also the Vice Chairman of Vice President of our Chamber of Commerce and Industries, ASIMA. So here, the Aba Chamber of Commerce and Industries is well represented. We have the organized private sector well represented. Clap, clap, clap. And then we have the academia well represented. Clap, clap. This is a balanced jury. And then next to the Cletus is technologist Peter Ekenachi. He is the chairman of National Association of Technologies in Engineering, NATE, Abia State. So we have, a balanced jury that we help to evaluate and score what we've done, and also help to determine who the winner or winners will be. So you have each team, so we are going to go around. So we have two sections. The first section is the evaluation of your class projects. So we'll go team by team, and then we will evaluate the projects, the class projects that you've done, and then we score. So we go around and we score. Then the second phase is the challenge. So this year, I'm very happy and proud to be an engineer. In fact, I'm not sure that any time in Nigeria to be more proud of engineering than now. Clap for me now. Because at this point, Nigeria is in a crisis of food insecurity, which has made the president of Nigeria to announce a state of emergency on food insecurity. So in a time like this, when the country is in a crisis like this, the country can look up to engineers as saviors to save the country. So that's why I'm happy and I'm excited to be an engineer. So we believe that engineers can help in saving Nigeria from this crisis. We believe engineers can help in solving Nigeria's biggest and toughest manufacturing, production, and engineering challenges. So this food crisis that we have in Nigeria, it can be solved by engineers. Yes. Engineers design and build the machines and the equipment that are used to mechanize and automate and scale up production of goods and food and other commodities. Why Nigeria is in a crisis of food is because Nigeria has not mechanized agriculture. Nigeria has not automated food production. And this is the work of engineers. True or false? True. So right here at the Nigerian Genius 2023, these finalists before us here, they have been tasked with the challenge to design and build a family robot which will help to mechanize and automate and scale up food production in Nigeria, while at the same time saving the lives of Nigerian farmers who are constantly being massacred on the farmlands. So I believe engineers can solve this problem. And today, we are going to experience, for the first time in the history of Nigeria, a robot that was designed right here at the Advanced Engineering Center, right here at the Nigerian Genius 2023. This robot that the world will see was conceived here, was designed here, was built here, and is working here. Clap for yourselves. So I cannot wait to put your robots in the farm and then see the robots farm, and then see you make me and other engineers around the country and around the world proud of engineering profession. Clap for yourselves. So the team will go around now, team of jury. When we get to your desk, present to us the class projects that you've done. Of course, for the training that you've passed through, the first 4 days of the Nigerian Genius was used for intensive training by industry experts on essential industry skills, on different manufacturing technologies, techniques, processes, and equipment, including computer-aided design, computer-aided manufacturing, CNC machining, 3D printing, laser cutting, welding, fabrication, drilling, all kinds of casting, all kinds of manufacturing and production processes. So when we get to your table, present to us the things you produced using those things that you have learned, the class project that you did, present to us, then we can see and we can test, and then we can score. So you will have about 3 minutes to explain to us, to show us, and explain to us the things, the class project you did, based on the training that you passed through. I hope it's clear. Okay, so we'll start with team FUTMINNA. So judges, please, we may proceed.
Yeah, good morning, sir. You are welcome. I'm Abubakar Musa Omare from Federal University of Technology, Minna, Department of Materials and Metallurgical Engineer. You are welcome, sir. Okay. This we have some class assignments that we have done. The first one is the fabrication, which we are asked to fabricate a steel stool and adjustable steel stool, and the top is made with a polymeric material, which is a wood. Yes, you can see it there. We fabricate it ourselves. Okay. This tool is fabricated with mild steel, a low carbon mild steel, and we are given a design. That is the drawing. We're given the drawing, and we follow the drawing and come out with this, which we are able to build it by ourselves, do the welding, the filing, the cutting, and the dressing, the painting, everything. This is the result. And this is the second project from the electronics. We decide to come up with this to make our design unique, and at the same time, this a lamp, but for a room, for a bedroom. You know, sometimes you don't need flashy light in the room. With this, it will look decorative, and it looks very okay. It is not too flashy. We can test that if you want to, and the strength of this something is very, very okay. It's strong and rigid.
Okay, please, can you tell us what you use to make, okay, for the stool, you say you use steel and wood.
A mild steel and wood, yes.
Which processes did you use? Operation did you perform on it?
At first, we were given the drawing, that is the design. Secondly, we select materials. Thirdly, we carry out our dimension by marking out according to the drawing. Thirdly, we start cutting. Fourthly, we start welding. Fifthly, then we dress. After welding, we dress. Sixth, we now cut the top layer. That is the wooden part. And we dress. After dressing, we gum because we need the edges tape. Then, after that, we now take it for painting. But after we what? Sandpaper it so that the paint should not look rough on it. Then paint to dry and assemble.
Welding?
Yes.
Okay, thank you. So we will test it now when they are done. Then this one, can you talk about what do you use to do what's the process?
The PCB will take through the PCB designing. After that, then we're asked to build up the panel. Then
do you mean you are trained on PCB designing?
Sir?
Do you mean to say that you are trained on PCB designing? Okay, I think
yes, we are trained on PCB designing.
Give your colleague, he wants to talk about it.
We design a circuit diagram with Bluetooth for the power supply, which the output is 12 volts and the input voltage is 220 AC. So we now design it like arrange components together that will be able to give us 12 volts DC. So after we have the 12 volt DC, then we design another circuit again for the LED, which was arranged in series connection, 3 LED arranged in series. Then after that one, then we now connect the output DC, which is the 12 volts, to the LED, so that it will be able to
said you have the LED bulbs on the top is your bed lamp, right? And each of the LEDs, what is their voltage? Because your input, your output voltage is 12. What is the, use a microphone, is the voltage?
it's 4 volts, which so each of the
Another question is important to your LEDs. Since the 12 volts.
improvement, or where do you expect it in the lab? Where do you expect this thing to be used?
It can be used in restaurants, even in an office, where you have tables plenty and
Yes, even workshops, because we make use of it in our workshop here too. So.
So, can somebody sit on it? Can I sit on it? Okay. So, but he's shaking. Why is he shaking? Why is he not stable?
yes, it's swinging because the pipes are not fitted. It's expected to be fitted, or it should be bearing head. Now, because due to material, there is no available material, so
Okay,
we
so-
make use of what's available.
How strong is it?
It's
very strong.
okay. It's very
So,
strong.
I can sit down?
Yes, you can sit
And I
down.
will not fall.
No, you will not fall. By His grace, you will not fall. Yawwa.
If I fall,
Hi. Alhamdulillah. More. Okay, you are walking already. Yes. It's in the hole. Yes, we created 2 portions of holes. No, it's not rotational.
can I dance when I'm on top of it?
Whatever you feel to do at it.
Thank you. So, start the.
Yes, we tested it.
Sorry,
Go on.
I missed the show. Okay, thank you. Any other question for them?
Sir.
Even drawing,
Radius 12. That is 30. Yes. Sir? Okay. Yes, around 300. So I actually want to do the calculation and tell you. Because Yes. Well, actually, the dimensions was given in inches. Everything is in inches. Yes, we work with inches. Yes, sir.
Okay, thank you.
Thank you, sir.
Okay, so this is team APU. Please go ahead. You have 3 minutes to describe the class project you've done. Talk about in 3 minutes, what you learned and what to use, how you use what you learned to build the class projects. Okay, thank you.
Hello everyone, good morning sirs. So we begin our Nigerian Genius competition for the past 14 days. So we start with the safety training, engineering safety training, the importance of safety in engineering works and our environment. So we learn the basics and what we need to do, the proactive actions that we need to put in place. And then after that we were taught laser cutting, how to use laser cutting to get solutions for some of our engineering challenges. And after that we went through the CNC machining class. Before that we did CAD, computer-aided designs for 3D printings and for other production engineering activities. And after that we did CNC machining, which is when you finish your 3D printing, if you need something in that, you can now take it to CNC machining to have a mold so that you can produce larger quantity. So after that we did our electronic class where we learn about PCB, printed circuit board designs, and also how to do the 3D printing as well. And after that we went through some print design exercises for like 4 to 5 days. Then after that we went to the...
Just talk about what you learned and how you applied it in the projects, the class projects that you want to present for us. So I think your 10 minutes is even up. Okay, you have 10 seconds more.
Okay. We learn different skills in engineering, and with those skills we're able to come up with our stool here. Although we have our own lamp as well, but there are some issues just of...
Why is it not here? It's not here.
Yeah,
bring it. Bring it. It should be here. Whether working or not, we should want to see it. About this.
Well, as for the stool, we are given dimensions to work on by the technician. So we went to the welding lab to bring out our, to first of all plan our dimensions and how we're going to work. So we put this up.
Okay. Any questions?
Yeah, I can see this now. Do you think this is convenient to hold?
Yes, sir. It's convenient.
Very convenient.
Yes, sir.
Okay. And you think that even a kid can handle this?
Yes, sir. Yes, sir.
Are you convinced that you did enough polishing here?
Yes, sir. We actually filed it.
Excuse me, and you don't think there's any hazard here? Don't think so. No hazard, okay. It's all right.
Yes, sir.
Oh, you are...
No. Yeah, obviously.
Okay. Okay.
Got some mistakes. So I was overwhelmed with some of my jobs, so I couldn't fully test
What?
The lamp is a dimming lamp.
Okay, thank you. Any other question? Okay. Okay, so Team UNIUYO, over to you.
Good day, everyone. This is Team
You
UNIUYO.
have 3 minutes to describe what you've done.
UNIUYO. So we are here to give a breakdown of what we've done. Classwork. So in our classwork, first we were given to do an adjustable single-seater stool with a footrest. You see the single-seater stool, we made it out of mild steel. And then you see the top here is a composite of wood and a steel. We have a support here under. That's the steel. So we actually supported it with screws to hold it in place. So we considered things before doing this. Consider the result, performance, that each should be able to carry somebody. Then it can carry somebody. Then we consider innovation. On innovation, we thought about 2 things. Innovations, safety alongside innovation. We had this knob here, this knob, but we don't want to leave it because it has sharp edge. You know, in engineering, safety is very paramount. So we consider what is an alternative, something softer than metal. So we thought about plastic. We had to 3D print a plastic to put on this. So this is our own innovation. So we also talk about now, because if this can be used everywhere, maybe in an office setting, if you're using a carpet, it will tear the carpet, that metal to metal. So we thought about using plastic to do it. So we cover the edges. Then the foot. Then we also considered economics. So for economics, we can see this is set at a particular level, so that because we consider anthropometrics. Human being, you can actually sit down. If you're tired, you adjust. Then let me talk about our lamp. Our lamp here is made from a full wave LED driver. The full wave LED driver, we had to step down the actual 240 volt to 12 volt using Zener diode and other components. So now we made that. The back here, we have our switch for time. You see, this is we did this is our switch. If you open there, we have a PCB there where we made it here and cut it from the PCB. Then actually consider everybody, because we don't want to make a lamp that anybody cannot use. So this thing we consider adjustment. It can be adjusted. You see the lamp here, see everything here. This is made here in this center. It's made of metal, it's made of plastic. We considered several things like balancing. So this is a counterweight. You can see if you adjust this like this, this is countering the weight of what we have here. So we made it angle 140. So from our design. So that's how we stand based on our classwork. It's lighting, we want to test it because we consider results to test it.
Okay, there should be an extension on your promise. Where is the extension on their desk? Where is it?
Welcome. Painted it again so that it will not corrode easily, so you can see it shining. That's why we had to paint again after the first coating.
To what he said, we are giving the drawing of this, but we're not giving what to do at the end, but we have to bring out our own creativity in making it do this.
Okay, thank you. Your time is up. Any questions from the judges? So can you adjust it? No. How can you make it up?
Yes.
And he will not fall. Okay. Are you falling, sir? You are checking.
My observation is that angle is not at 90 degrees.
Okay, this is what happened. After police, we actually kept it there. You know, we kept it at the workshop there. Okay.
Of 90 degrees.
It is a bit good.
You know, this is a reading lamp now, isn't it? It's supposed to have a reflector, don't you think?
Sorry?
A reflector.
Reflector.
So that we're able to capture.
Yes, we worked with the materials we have available.
All right. Let's leave it at that.
Okay, thank you. Thank you very much. Okay, so team Yala,
Yes,
so you have 3 minutes to walk us through what you've done through the training, and then we test it. Thank you.
Okay, sir. Good afternoon, everyone. My name is Olayinka Oyewole from YABATECH of Technology. So during the first 4 days of the Nigerian Genius, we went through several trainings, and one of the training we had was welding and fabrication. And after the class, we were given a project to work on, and this is the project, an adjustable stool. So how this came up is that we were given a design to work with. The design has the structure and the different dimensions of the different parts. So we were provided some materials with which we used to came up with. And this is a wooden platform for sitting, and this is the foot support, and this is also a steel base, and also this is an adjustable knob. So during the welding process, me and my team, we distributed the work. Some was working on this, some was working on cutting, some was working on welding and all of that. So basically, this is adjustable in 2 levels. You can adjust it down or up. And also, we believe this is strong enough to carry, of course, anybody that will sit on it. Yes, sir. Okay, so
we are on circuit design, which we designed a driver software with our own design. After we came up with our own design after the class, and we had to use the CNC machine because we also had a CNC class as well. So we had to use the CNC router to design our PCB to engrave the circuit parts on our copper clad which we had. So after that, we got the components. Our instructor gave us the components we'll be needing, and we used that to assemble this. And David is the card guy among us, so he is into the design stuff. So he came up with this design that we should use do something like adding a wall clock. It will be more of like the wall clock, where the clock will be in between, and we have the lights down. So that's how he came up with this design, and we've tested everything, and it's working.
It's okay, let's test the stool before we come to your lamp. Yeah, the tallest. I think you are even the tallest here. Wow. You. Okay. Now, bring it up. Explain to us why you made this like this. Just this adjustment.
We actually did this because one, the queue for cutting, welding, the whole stuff was wasting time. So instead of doing too much design, we decided to come up with something easier we can quickly work with, so we can move on to other stuff.
Okay, others, we are wasting your time, and you decided to waste time for this one. It's okay. Quickly, let me ask the tall one. What's the diameter of this? This sitting
around
area?
26 diameter. 20
26
centimeter diameter.
26 centimeter.
Yeah.
And if we measure it now, it will give us that. Is that what is giving you in your drawing? The diameter they gave you in drawing, what is it?
it was 30 centimeters.
30 centimeters.
Yes.
Okay. It's all right. You removed the 4 because.
Okay. So where do you intend this thing to be used? Is it in the kitchen, at a football pitch? Where? I want to know where you intend this thing to be used.
It can be used in the office. Yes. Anyway.
Yeah. Open office.
Yes.
And a place like this.
We're actually working with the materials available, but we're considering adding something like a foam and a cover for it, so it will be soft enough. This is not something someone can sit on for a very long time because of it is just metal. But due to the fact that that's why we just had to leave it this way. And other.
So can we get the other one?
Yes, we can do that, sir. It is the power supply which we designed during our PCB design class. So we used the idea we got from the PCB class to design and also the knowledge. Yes, like a power supply. It's actually no sir. No sir. It's actually a wall. We designed it for wall mounting purpose. Like you can mount it on a wall. A light. Yes, exactly, sir. Exactly, bulb. Yes, exactly, sir. Yeah, we designed it for wall mounting purpose.
Okay, what do you make it like this? It looks
this.
What you have to shoot out? Is it bullet or knife or something?
No, this side will be facing. So it's more like just indicating the direction of which.
Okay, you show the direction.
Yes, this is facing
up.
Yes, mount it. It's
okay.
So you don't just mount it
anyhow. Okay. That's thoughtful. Okay, thank you. Clap for yourselves, all the teams. Clap for yourselves. Okay, so thank you. So we'll take a short break, maybe 10 minutes break, so that I can prepare for the testing. So when we come back from the break in 10 minutes time, we'll go to the farm so that your robots can farm for us.